distraction. All right, so let's start by opening a new model. So we want to develop a system dynamics model for thermostat controlled heating system that simulate the temperature and energy consumption in the room. Hope you guys can hear me. Wait, can you guys hear me? Okay, you can hear me. Okay, great. So anyway, so I use ChatGPT 4 to help me like explain, because I know that I'll run into some problems locating some stuff and some definitions here. So I just use ChatGPT 4 to get some stuff. So I'll just be walking you through what I know and what we're trying to achieve. So first thing, I create a model and do the normal stuff. So heating system. So that's the name of the model. So basically what we want to do, because some people have already done it. So the issue that they had was that their model was not, the region was actually opposite of what's meant to happen. So what we want to do here is we want to supply heat into a room, and we want to set, we have a desired temperature 25 degrees Celsius, and we want to supply heat into the room. We want to see how long it will take for that room to reach 25 degrees Celsius at a certain energy consumption rate. So for you to generate heat, you need energy. So energy is being supplied to the heat generator or whatever it is. So as the heat is entering the room, the temperature of the room, it has to increase until it reaches the desired temperature. So that's what we want to do. So let's just follow along. So the first step, we've created a model. This is the model heating system. So the first thing we want to do is go to your palette and look for stock. So what I usually do is I just click on the palette. You can see my cursor. Click on the palette and type what you're looking for, stock. It's going to take some time to load, but just wait a little bit and you will see the elements pop up quite soon. The software is kind of slow, so just give it some seconds. Some people already know where it is. You can search, go to system dynamics, look at all these icons here, look for system dynamics, then you see the stock. Or I like to search for it. Okay, so that's it. So stock is notified or identified with rounded corners. It's a square with rounded corners. So that's that. So that's it. So we said we should name our stock element what room temperature. So on the right we have our property panel. That's where you set parameters and everything. So go there and type room temperature. So I've said that. Now they said we should set our room temperature to what initial value of what 20 degrees Celsius. 20 degrees Celsius. I mean, we can also put the dimension if you want to do that. Well, that's not necessary. So I mean, you can explore all those things yourself. But for now, I'll just keep it simple. So room temperature. So I've done that. So we are done with step 2. Now step 3. Look for the flow elements. Flow elements. Now the flow elements is what. So in the system dynamics that we taught, there's usually a diagram we have. You see flow elements. You see stock. I don't know the name, but flow element basically just shows direction of movements. So cause and effect, something like that. So sorry, the name is flow. Sorry, look for flow. So type flow in your palette. You'll see there flow. So simply drag it there. Now the flow. Now the question is, where is the room, the stock going to be? The flow is usually characterized by an arrow. Then which on the left and the right you have 2 clouds. Now that 2 clouds are the source and sink. One of them is the source and the sink. The source is the one on the left. The sink is the one on the right. So heat. So when something is flowing, basically we want to supply temperature to the room. So if we're going to put our room to the right, so that is our sink. So the heat is going from the source, from an external source to the internal source, which is the room. So we flow. So we call it flow. So we name our flow was heat flow. So you go to property panel and call it heat flow. So heat flow. So we are done. And okay, is there any other thing? Okay, set is to connect it to the room temperature stock. Set is equation to K multiplied by desired temperature minus room temperature. Now this keyword desired temperature, room temperature has already been defined by as a stock. Room temperature is stock. But now you notice that we don't have what desired temperature, and we don't have K, which is a constant. So we need to do what? We need to set those values. We need to define them somewhere. So what do? So we go to the properties panel again, and we look for something called variable. Who is joining this meeting at this hour? Oh, sorry. So back to the lesson. So we look for what's variable. Okay. So dynamic variable. So look for dynamic variable and simply what? Drag and drop it. Drag and drop it. So we have brought our dynamic variable. So we have to name it what? Desired temperature. Desired temperature. I think someone asking a question. Okay. Desired temperature. I don't know if someone is asking. It's not a question that I'm hearing that sound. So desired temperature. So the desired temperature we set it to. So okay, we put our desired temperature. So set the equation to K multiplied by desired temperature minus room temperature. Now then, okay, we also have to define our room temperature. So we also need to duplicate this. Yeah. Yes. Yes. Do okay. Do you have parameter as a element in your palette? Okay. Yes. 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 Thank you. Yes. Thank you. So parameter. So dragging your parameter there. So your parameter, you put it since it's okay. Thank you very much for that. So dragging your parameter and desired element since it's a constant. So you put it there as 25. 25. 25. So if you look at the advanced panel there, you see that it's static. It's not a dynamic stuff. So and the static ones actually you kind of see this black stuff in it. So set it to desired temperature and okay. Then your K is also a constant. Your K is also a constant. So I think we should also have that too. This software is not going to delete that. So let's rename parameter desired temperature. So I'm going to speed up the temperature. Okay, so I've set down to 25. So the K is a constant, so I can still use this. So just Control C, Control V. Now we're going to link everything soon. So there's a need for you to link all your elements, which we will do after all. But let's just do this first. So let's call this K. K is a constant that represents the heat coefficient. So let's say 0.1. 0.1. So those are constant values. So now we go back to our heat flow, and now since we have defined those two values, which are kind of like constant, we can set our heat equation. So I'll just copy the equation K multiplied by desired temperature minus what room temperature. Now when you put in the formula, you will see something like an X beside it telling you that these things is used but not expected. It means that you need to link it. So when you double click on that, ideally it should link it for you. It should link it for you. Is the software hanging? Oh, sorry, software is hanging. It should link it for you actually. But okay, anyway, another way you can do it is right click, then right click on any element, then you see fix dependency link, create missing link. So it automatically links everything for you. So normally there's a link element in your palette which can drag and drop stuff to link things. So anyway, use a value or something like this desired temperature, okay, and you put it in a formula somewhere. You need to link it so that it knows where you are getting that value from. So that's the function of the link element. So we are done with that part. So now we're moving to next part, number 4. Drag and drop a converter element from the palette viewer and name it desired temperature. Name it desired temperature. Set the value to 25. Represent the desired temperature of the room and in degrees Celsius. Degrees Celsius. Okay, degrees Celsius. Okay, basically. So I think we have done that already. So now, converter elements. That's the question people were asking one time. Which one is converter element? So there's no like a element called converter element. Actually, there's not like an actual converter element. So what we use is either use parameter or dynamic variable. Variable basically. That's what you use for converter. Converter is just why it's called a converter element, because you are using it to convert whatever you're having here. That's just what it means there. So next one, number 5. It says drag and drop another converter element from the palette and name it energy consumption. So let's drag and drop another one from the palette, name it energy consumption. Set the equation to. So now this one is not going to be a parameter. The next one we want to draw is energy consumption. So we'll look for the word variable. This one is going to be variable. Why is it variable? Because it's changing. It is changing. So variable. Yeah. Sorry, I'm recording this thing. So I like asking back and forth. If you just want to if you notice any issue, you can let me know. But I'm recording the call, so back and forth will make it a little bit longer here. Sorry. So the next one is the energy consumption. You can put it anywhere you want, just make sure it's a little bit neat. Okay, so energy consumption. Energy consumption, I use dynamic variable. Why? Because it is something that is changing. So energy consumption. Now the energy consumption from the distance, set the equation to what? Heat flow multiplied by C. Heat flow multiplied by C. So now you see the keyword there, heat flow multiplied by C. So heat flow multiplied. So just put it inside here. Heat flow multiplied by C. Now you see that. So now what do you think we should do with the energy consumption? The energy consumption should be linked to the what? Heat flow, because the energy consumption is making use of data from the heat flow. So if you right click on it, you see fixed dependency link. It automatically links the what? Heat flow to the what? Energy consumption, as you can see here. So that's a quick way. Instead of you going here to look for the link element. So whenever you are connecting two elements have one relationship, you use the link element to connect them. If not, you have error. So we're done with number 5. Okay, they said we have another constant here, constant C, which is what they said you use assume 10. So just like the K is like the C. So we duplicate the K, Control C, Control V. So if you have done that, you call it C with the value of 10. Now don't forget that you need to what? Link your C. You need to link your C. So right click. Okay, sorry. Click on energy consumption again. Check for what? Create missing links. It automatically what? Links your C to the energy consumption. So that's what I do. I mean, there are other ways you can do it, but that's the way I discovered. So I mean, there are other ways you can do anything I'm doing right now. So we're done with number 5. Number 6, drag and drop a time plot element from the presentation and name it temperature plot. So we get our time plot. So we just call it it's called time plot. So time, the software is actually slow. Time plots. Wow. So you drag and drop it somewhere. Now your time plot, they say we should name it what? Temperature plot. So I just copy the name, temperature plot. Temperature plot. Now they say set is data to room temperature and desired temperature. So now some people are using data sets. So it's not data set, it's value. Data set, you're going to basically provide you with the data. So we cannot provide data. So the title of the chart is what? Temperature plot. Now the value, where is it getting the value from? Now the data is gotten from what? Room temperature. So what you want to do, you want to display the room temperature on this chart. So you put room temperature there, and yeah, you can color paint it or choose any color of your choice. Now we want it to display 2 charts basically. There's the second chart. Sorry. So the second chart should be showing here. Okay, showing. Sorry, I think that's it. Okay, second chart is what? Desired temperature. So the same chart plot can have 2 things. Can be displaying 2 things. So the second one is desired temperature. I will paste it there. So so I think that's clear. So let's check it out. What we've done. Okay. Oops. This is not showing fully. Okay. I thought I did plus. Okay, let me do it one. Let me change one to red. Okay, red. So okay, the first one is sorry, let me do that again. But you understand what I mean? So all I want to do is set your data. The first one, let's name it room temperature, and the value is getting from room temperature. Now the second one, this thing is glitching. Click plus. This thing is glitching. Let me do this full screen. I'm meant to see my second chart displaying here. Wait, so let me delete this plot again and put it back. This plot is stubborn. So I'll do that again. So like I said, we have the plots and the name. So I select the plots, then it should show on the left. So okay, so our first one is we want it to display room temperature. So the first graph we have room temperature, down. Now the second one should show at the bottom. Okay, the second one is gold. No, the second one is green, but it's not showing. Does anybody know what the issue is here? I'm going to close and open it again. Sorry. Well, if you have done that, the next one you should do is to put an outline plot. Yeah, this one shows. Okay, great. It's showing now. Alright, great. So this is what I want to do. So the second one is we have the room temperature. Then we have the. He said we should do two. The second one is desired temperature. Desired temperature. So that's our yellow green. So let me just change this to red. Alright. So now you want to make sure that your legend is displaying properly. So you can stretch your graph to display everything properly. So let's drag an outline plot. Now, so we have the one that is reading for this, and so we'll go back to the question. Now, number 7 says we drag an outline plot, name it energy plot, and set the data towards energy consumption. You guys can try that out quickly. So click on the second plot and do what you want to do. The software is too slow. It's definitely on my system. Okay, so second plot, energy plots. We are using the energy consumption. Now for the plots, we don't need to link it. For plots, you don't need to link it. So I prefer to use this color. So after all that has been done, you check for any error. So if you go to the bottom panel, you see error there. So that's for another code. So thank God. So the code is not. So you can check the errors on your code, or sorry, on your model by just clicking the small icon beside the error, and you'll see a problem panel showing where the error is. So now in this case, this is for the second question too. I've not yet run this one. So it shows the location. The name of the model is Predator Prey. So you can go to Predator and you see that's the second question. So we don't have any issue with our code, so it is good to go. So once you are sure that everything is good to go, you simply click. Stay hanging like this. You simply click the word run, and make sure that you are running the heating system simulation. And yeah, it should show up anytime from now. Any second from now. Yeah, this software is extremely slow. Alright, so that is how you do the stuff basically. So you can see what is happening. We're trying to measure the time it takes for it to get for the room temperature to reach the desired temperature, as you can see that. So after some seconds it's going to reach there. So you can play with the tool and add there's something called slider. I'm not going to do any of those ones. You can do that yourself. Explore this. There's something called slider anyways. So you use the slider to control variables. So you put the slider here and basically connect it to any of these things. So you can use it to like watch what happens as increase and decrease it, especially for those variables. And there's also other tools like experiments. If you type experiment here, you see experiment and see what you can do with that. So that's the end of question 1. There's no question, right? Yeah. Alright, great. So so with that knowledge, I think you can be able to do the second one by yourself. So thank you very much for your time. I think that's the end of this thing. The second one is just basically straightforward. Same thing. You just need to know where the flow is connected to. Let me see that's open. Is it hanging or is it not open? Okay, let me just see. I just want to show you how it looks like. Yeah, it's pretty rough, but you get the logic. So basically what we're trying to do for this one is we're trying to see I'm just going to run through it. What we want to do is develop system dynamic model for a predator prey system that simulates population dynamics of wolf and rabbit in the system. So basically we want to see how is the wolf and rabbit growing, and someone was waiting since the meeting is over already. Sorry. So basically we just want to see how the rabbit and the wolf is growing. So the rabbit, as the rabbit's birth is increasing, you know that rabbit birth is basically increasing the population and the death is decreasing it. So it's just a matter of how you put your flow. If you put your flow in the wrong way, your graph is going to look somehow. Some people have that issue. So make sure you put your flow in the right direction. So the rabbit birth increases population and the rabbit population is being decreased by rabbit death. So that's why the flow is going like this. Same thing with your wolf birth. Wolf population is being increased by wolf birth and decreased by this. So you want to visualize what is happening there with you basically want to visualize the population growth and fall for the wolf and rabbits. So using the same principles, I mean, there's nothing new here. You can be able to simulate that. So I'll just give in for any question. There's any question? Is there any question? Let me end the recording now. Hopefully somebody understands this recording.